Have you ever gotten tripped up trying to remember the difference between a rhombus and a parallelogram? Or maybe you've wondered, what's the big deal with squares? Well, you are definitely not alone. It turns out the best way to get all these four-sided shapes straight isn't to just memorize a long list of rules. Nope, it's to think of them as one big interconnected family. And today, we're going to map out that entire family tree.
So let's kick things off with a little puzzle. What on earth do a door, a diamond, and a kite all have in common? I mean, they look completely different, don't they? Well, when you look at their geometry, they are all part of the very same family. And by the end of this, you'll see exactly how they're all related.
All right, to build our tree, we've got to start at the very beginning, at the root. We need to meet the one ancestor that unites every single shape we're going to talk about. And here it is, the quadrilateral. You can think of this as the great-great-grandparent of the whole clan. The only rule to get into this family is super simple. You just have to have exactly 4 sides. That's it. Nothing else, not angles, not side lengths, matters just yet. Any 4-sided shape you can dream up is, at its heart, a quadrilateral.
You know, like in any big family, you eventually get a major split, usually over some big disagreement. Well, in the shape family, it's all about one thing: parallel sides.
And this is where that big split happens. On one side of the family, you've got the trapezoid. Its rule is that it must have exactly 1 pair of parallel sides. No more, no less. But on the other side, you've got the parallelogram, which is a bit more structured. It demands 2 pairs of parallel sides. And just like that, this one simple rule divides the entire family into 2 huge branches.
And for the trapezoid branch, those 2 parallel sides are a really big deal. They're so important they even get their own special name. They're called the bases. That's kind of its defining feature.
Okay, now let's jump over to that other, way more complex branch of the family, the parallelograms. This is where things start to get really interesting, because this branch is going to give us some of the most famous shapes you know. So every shape that comes from the parallelogram inherits a certain set of family traits. Think of it like their DNA. Not only do they have 2 pairs of parallel sides, but their opposite sides are always the same length, and their opposite angles are always equal too. These are the non-negotiable family rules. So what happens when a parallelogram decides to get a little more specific? Well, first up, let's meet the rectangle. It takes all those standard parallelogram traits we just talked about, but it adds one very strict new rule for itself. All 4 of its angles have to be perfect 90-degree right angles. Now, the rectangle's sibling is the rhombus. It also starts out as a parallelogram, but it decides to specialize in a totally different way. The rhombus doesn't really care about having perfect right angles. What it insists on is that all 4 of its sides must be the exact same length. And this is the perfect way to picture it, right? The rhombus is what we all immediately recognize as that classic diamond shape. Every single time you see a diamond on a deck of playing cards, you're looking at a rhombus. So it really just boils down to this. They're both parallelograms, for sure, but they each have their own special thing. Rectangles are obsessed with angles. Rhombuses are obsessed with sides. That's the key difference between these 2 siblings. Okay, this brings us to the most exclusive, most famous member of the entire quadrilateral family. So what do you think happens when these 2 powerful family lines, the one that's all about right angles and the one that's all about equal sides, finally come together? Just think about it for a second. What kind of shape would you get if it inherited that super strict rule from the rectangle and the super strict rule from the rhombus? It would have to follow both of their demands at the same time. Well, you get the shape that truly has it all, the one that combines the absolute best traits from both sides of the parallelogram family. The square? That's right. A square is basically the perfect child of a rectangle and a rhombus. It's got 4 equal sides, which makes its rhombus parent happy, and it's got 4 perfect 90-degree angles, which makes its rectangle parent happy. It is the absolute best of both worlds. And this is what makes the square so special. And also a little confusing. Get this. Since a square has 4 equal sides, it technically qualifies as a rhombus. And since it has 4 right angles, it's also a rectangle. And of course, since it has 2 pairs of parallel sides, it's a parallelogram. A square is kind of the ultimate shapeshifter. It's a member of all the most exclusive clubs in the family at once. But wait, not every 4-sided shape fits so neatly into that main parallelogram family line.
There are a few outliers out there, some, let's call them quirky cousins, who kind of march to the beat of their own drum.
First up, we've got the kite. Now, the kite's rule is totally unique. Instead of caring about opposite sides, it says that its adjacent sides, that means the sides that are right next to each other, have to come in 2 equal-length pairs. This one little difference makes it a very distinct cousin, totally separate from the parallelogram branch.
And the last but not least, we have the true rebel of the family, the irregular quadrilateral. This shape follows only one rule, the original ancestors' rule. It has 4 sides. That's it. No parallel lines, no equal sides, no special angles, nothing. It's the most basic, free-form member of the entire family. Okay, this slide right here pulls everything we've talked about into the ultimate cheat sheet. Seriously, you can think of this as the genetic code for every member of the family. You can see in a flash what makes a rectangle different from a rhombus, and how the square literally inherits traits from both. It's the entire family tree in one simple chart. And this is where it gets really fun, because this quadrilateral family isn't just in a math book, it's all around you. Now that you know their family rules, you can start spotting them everywhere. Is that window in your house a rectangle or a true square? Is that tile on the floor a rhombus? You now have the secret code to place every 4-sided shape you see onto its proper branch of the family tree.